A bit too loud.
Yeah. It's very loud. 1, 2, better. Okay, so let's go. I speak in English because Dux is our speaker today. And first, Happy New Year's for all of you, and thank you for coming to the Performance User Group. And as I said, we have the honor to have Doug Sillard today with us, mobile expert developer, Google expert, and author of Norway book. And today, Doug will speak about delivering fast and beautiful images, better than my slides. So I will, in a few seconds, let him talk, and after it, we will have just a lunch to continue speaking. And to finish, just a word about our sponsor, Octo, that provides us the room and the buffet for 5 years now. Octo is hiring. Boremi and me are both of Octo, so if you are interested in performance, in big data, in cloud applications, or in everything we can do at Octo, don't hesitate to tell us and speak with us. So now, Doug, welcome and thank you.
Great, thank you. All right. All right. Bonsoir. I studied French in high school, but it's been a very long time. So, pardon. I'm going to give the presentation in English here. So, if you have any questions or if I'm speaking too fast or anything, just holler. I'm going to talk today about web performance, and a big important part of web performance is how we deliver big files. And when you think about big files that are delivered on the internet, images and video are some of the biggest files that we deliver. Before we start talking about that, just a little bit about me. I'm Doug. I do freelance developer relations, so I help people, help companies figure out how to talk to developers. It just went out. All right. If it goes out, I'll just talk. I look, but if I look this way, it works. Oh yeah, see, science. It's science. Yeah, I touched. All right, we'll just put this right here, and maybe I'll just hold it. Yeah, don't worry about it. This is fun, right? And now it works. That's fun. All right. Okay, so developer groups. I do a lot with performance. I try to help people build websites, native apps that are fast, because things that are fast, people like to use. I do workshops and things. I wrote a book. Oh, all right, we'll figure it out. I won't move. I'll just be very. All right, so I wrote a book on high-performance Android apps. If you have any questions about performance, I'm the only Doug Sillars on the internet, so I'm pretty easy to find. If you want to download my book, that's the PDF, so you can download that. I'll post the slides up on the meetup later, so you can download it, get the URL later. Before we start talking about performance, this is in Switzerland. And how many of you get nervous about walking across this walkway that's like nailed onto the side of an Alp? Anyone? There are a couple hands, right? Yeah, it's. I walked across this with my family, so I've been traveling in Europe with my family for the last 2 years. And we were walking across that, and my 6-year-old decided to jump the whole way, so it like rattled, which added a little bit more ambiance to the whole thing. But related to performance, Ericsson did a study about 2 years ago where they put sensors on people's brains to measure stress responses, and they found that thinking about queuing up for a line raised people's stress. People thinking about walking on the edge of the cliff felt more stressed out. But interestingly, experiencing mobile delays is actually more stressful to people than standing on the edge of a cliff. Think about when you're standing on the edge of a cliff, customers feel when we build a slow mobile experience. I'm trying to figure out where to hold this. This is fun. All right.
Sorry about that. Really sorry.
Oh, no.
Yeah, we'll just replace the cable.
All right. This will work. All right. So basically, you want to make sure things are fast so we're not stressing out our customers, because if our customers are stressed out, they're not enjoying the experience. And if they're not happy when they're on your website and you're trying to sell them something, they're less likely to buy. When people are happy, they're more likely to spend money and things like that. So that's a good thing. We want to keep people happy. Other stats, you may have seen some of these before. Google's found that a 3-second delay causes 53% of people to abandon a mobile website. A half-second delay increases frustration, lowers engagement. These really old studies, both from Amazon and Walmart, found that every 100 milliseconds causes 1% drop in revenue. But my favorite study is 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So if you ever see somebody with a cracked screen, it might be because they were seeing a slow app and they just chucked their phone across the room. So as I mentioned at the beginning, when you think about what makes up the web, and this is the average size of a web page from the HTTP archive, and if we look, videos 25%, images are 50%. Now you might be thinking, well, how can video be 25% of the average website when most sites don't have video? It just turns out that when there is a video file, it throws off the average so significantly. Just like if Jeff Bezos came and sat right over here, the average salary in this room would be about $150 million a year, right? It just throws off the average. So when you put video on your site, that ends up being a huge chunk of the data. So here we are, we've got images and video, we want to reduce it, and images and video can be expensive. I've got an Irish SIM, and I just recently was going to Russia, and I was like, oh, I wonder how much it'll cost me to go to Russia. And roaming in Russia is €10.24 a megabyte. And we'll see some websites later on in the talk where we'll just use this Russian conversion to see how much money this would cost me, because that's pretty expensive. Especially when you start thinking about, this is an 80 euro image, right? This is Porto in Portugal. And so it's 7.9 megabytes. And, images become bigger the more color and differences and things that happen. This is a very colorful image. It's really beautiful. About 2 weeks later, I was in a different part of Europe, took a picture with the same camera, and it was only 3.5 megabytes because it was pretty gray. This is Oslo in November. I think Oslo is probably very beautiful. This looks like, I'm from Seattle. I lived in Seattle for 15 years, and this is what Seattle looks like for most of the winter too. So I can't really say anything bad. But just changing the colors on an image, same camera, but when it's just one color, it compresses a lot better. So if you want to, obviously post photos that are all almost monochromatic, you'll save a lot of data. But we don't want to do that. We want to post pretty pictures when we do things on the internet. So I want to walk through 4 simple image optimizations. These all come from Lighthouse. Do you guys know Lighthouse? All right, it's a lot. Okay, I see a couple yeses and a couple no's. So Lighthouse is a Google optimization audit. It looks to give you optimizations on how to make your page load faster on mobile. It's in Chrome DevTools. It's also part of Web Page Test, which I'll talk about in just a second. But the 4 optimizations that are in there is to optimize image quality, image format, image sizing, and lazy loading. And these are the scores from last year. They've changed it from 0 to 100 or 0 to 1. But basically 0 is bad, 100 is good. And it used to be you only got 4 possible scores. It's now more of a continuum. But what's really cool is when you run a test with Web Page Test, webpagetest.org, you can get Lighthouse scores as a part of that. And there's this really cool tool called the HTTP archive. And it runs Web Page Test on 1.2 million sites every 2 weeks. And then all those results are thrown in BigQuery, so you can look up all that data. So what ends up happening is the HTTP archive has Lighthouse data for 1.2 million websites, so we can look to see how these 1.2 million websites are doing on these 4 simple image optimizations. That's kind of what I'm going to talk about here. And so the first one we'll bring up is image quality. Lighthouse recommends that you save all of your images at 85% quality. And so when you do 85% quality, that's a lossy save. You're going to lose some of your pixels there. However, at 85%, for the most part, no one can tell any difference on the web. So Google said 85% in general is really, really good. In ImageMagick, you can save it at quality 85, and it outputs a quality 85 image. Cloudinary is a cloud-based image tool, so you upload the full-size image, and then you just insert quality 85 in the URL, and it spits out a quality 85 image. So what does that look like? So here's a picture. This is Riga in Latvia, 3.6 megabytes from my phone. I save it at 85%. It's 1.87, so it's half the size immediately. So pretty huge savings. If we look at the HTTP archive, we find that 43% of websites pass this, but a full third of the internet is failing this completely. Those sites that fail it on a 3G network would be 2.8 seconds faster and use 400 kilobytes less data if they optimized. If we went down and saved it at 50%, obviously it's a lot smaller. You can start seeing some pixelations and some deformities in the image. And obviously if you go too low at 20%, you can see it in the sky. You can see all the gradients forming in there. We don't want to do that. So if we look at the data, we know that 85% Google says is okay. We know down there isn't okay. Wouldn't it be cool if there was a tool in between that would give us the data that would find the optimal spot in between automatically rather than just picking and choosing? And there are tools like that. There's Booter from Google. There's structural similarity. These are algorithms that find that optimal spot where the human eye can't tell a difference. This is an open source tool called CJPEG DSSIM. You can use Cloudinary, say QAuto. It generates that for you on the fly. And we're right in the middle. It's at 1.46 megabytes. Your eye can't tell the difference between this image and the original 3.6 megabyte image. And you can see here we saved another, 400 kilobytes from the Google recommendation. So 400 kilobytes more, that's pretty significant. We should do that if we can. If I plug those into web page test, right, I'm testing on a Motorola G4 on a 3G connection. The full-size image takes 21 seconds to download. Structural similarity, I get down to 9.5 seconds. Way, way faster. 3.8 megabytes down to 1.5 megabytes. You can see this is a good improvement. We've got 3 more optimizations to go. The next one we can talk about is image format. There are a bunch of different image formats. These are the average sizes, again, from the HTTP archive. You can see there's JPEGs, we've got SVGs, we've got WebP. Let's talk really quickly about vector graphics, because vector graphics are really cool. If you have a vector graphic, they're images drawn as shapes, so you can stretch them. They're infinitely scalable because they're just vectors. They're written basically in XML. And so you can take the Twitter logo and you can stretch it, and it looks great. You may see some deformities here, and that's just because PowerPoint doesn't actually take SVGs, and so I had to take screenshots to paste anyway. In general, they look great no matter what size you're looking at, but you can screw them up. This is a graphic from a site in Brazil. They put the Facebook logo on the web page. That's great. But if you look at it, I can open up the XML, and there's this Adobe Illustrator stuff on the inside of this page. And it turned out that Adobe Illustrator added about 1.3 megabytes of extra stuff to this XML file. So when I went into the XML, deleted all of that, it was 900 bytes. So that's, when you're doing things like that, you should probably test it before you push it to production, because this was live. They're like, we made an SVG, push it, right? It went live. And then, of course, because it's XML, you can gzip it, or you can use Brotli, and you get it down to like half a kilobyte. So, do the right thing, but then test it afterwards before you push it live. But though I would like to talk a little bit about WebP, because the average WebP is half the size of JPEG. WebP is a Google format. It's based on a video codec, is based on VP8. And because it's a newer format, it compresses a lot better. You can see the average size is a lot smaller. And for a long time, there was a lot of concern about support for WebP. It was only a Chrome thing. But in the last in the last quarter of last year, we got support for Edge, we got support for Firefox. We're kind of still just waiting on these guys, and they're working on it. So WebP support is coming, and so when you have WebP support, we could generate this image as a WebP, and we're down to under a megabyte now. So I did structural similarity, I made it a WebP, and you can see when I load it, obviously I load it as a WebP, I have a fallback to JPEG for our Safari users, because Safari. Have the alt tag, of course, and then you can see for the WebP, I've shaved off about 2.5 seconds in load time, and 500K, right? That's pretty significant. When we look in the HTTP archive at Lighthouse, 2/3 of the internet is not doing this. It's a pretty significant gain by going to WebP. I did this study before there was that widespread support in Edge and in Firefox. It was just Chrome, so maybe this has improved a bit. The median website would be 4 seconds faster and 600K less data on a 3G connection. Pretty significant savings just by switching from JPEGs and PNGs to WebP. Of course, we can resize all of our images, right? So you take this picture, it's 12 megapixels, it's 1.6 megabytes. You optimize it down to 800K, but it's still 12 million pixels, right? And then when you download it to a mobile phone, you're not showing 12 million pixels on the phone, you're showing, I think this is 500,000 pixels. And so, 12 million minus 500,000 means that you're downloading almost 13 million pixels, and you're throwing away 12.5 million. So when you end up throwing away 95% of the data, 90-something% of the data, it's sort of a double taxation. It takes forever for the thing to download, and then the CPU has to fire up to throw away all of the data that you just downloaded to put it on the screen. And this can actually be pretty significant. On some lower powered phones, I ran some tests. I don't think it made it into these slides, but on like an Alcatel 1X, which is an Android Go device, it was adding like almost another 850 milliseconds to remove all of those pixels. So in addition to the download time, then you have to worry about the processing time of almost another second to get that on the screen. The best analogy for this in real life is like when you order something from Amazon and the box arrives and there's like 8 meters of brown paper on the inside of the box, and you find out that your kids ordered like a pencil and it came in this giant box. So we can optimize. Of course, these are the Android devices that are out there. This is a chart of all the devices that hit Akamai in one day. So the size of the box is how many of a certain model. So these are all Samsungs. The color is how fast the processor is. So you can see there are a lot of devices out there that don't have a huge market share and have really, really slow processors. And that's where you start seeing that 1 second in processing time for those images, which gets really, really expensive. So as you might expect, what we do for this is we have responsive images. We generate a bunch of images. One approach is to do 25 kilobytes different in size. So I generated a whole bunch of those, and I end up only wasting 100,000 pixels now, right? This is 625,000 pixels. It's showing up 519, so way better than throwing away 12 million. There are a bunch of tools out there that will do this for you automatically, so you can do this as part of your content management. Every time you upload an image, upload the different sizes, right? So in this case, I'm doing a whole bunch. I'm doing 20 different images between 20 and 200 and 1400 pixels wide. You end up with, this is what your HTML will end up looking like. And just because I can do a quick demo, this page will load. Oh, it didn't switch. Awesome. Let me go out of presentation mode. It's on a different screen. Let's see if I can find it. Which way did it go? There it is. Awesome. But now I need to find the corner of the screen. So, whoa. Is that the corner? Not quite yet. All right. It's a big image. All right. So when I resize this, you'll see different sizes of the image download. And when they're 25 kilobytes apart, you'll see the difference because every other image is sepia. So is this resizes? I think this is resizing. But 1400 pixels is the biggest image, so I have to get pretty small. It's a big screen. All right, so you can see these images are all 25 kilobytes different in size. It doesn't take a lot when the images are big to make 25 kilobytes different in image size, but you can see for your smallest device, your smallest thumbnail, you're going to get a perfectly sized image that's itty bitty. This one's like 25 kilobytes. The biggest one is like 400, but it's going to be perfectly sized for your device. Let's go back to presentation mode. Let's hope it works. There we go. All right, so that's what the code would look like. And just to show, I used Cloudinary, and every other one I have this sepia tag to make it sepia. And I just changed the width, and it generates those for me on the fly. So when I make a responsive image for a Motorola G4, it's all of a sudden serving just 121 kilobytes instead of 1 megabyte. So the load time drops by 5 seconds, right? That totally makes sense. Responsive images are pretty well done, pretty well supported. Only 20% of the internet is not doing it at all. 80% is doing it to some degree, 60% is doing a really good job at this. This is sort of like mobile first, so a lot of people are doing it. But for these sites that aren't doing it, it would be a huge improvement. Again, that median site who's failed would be 2.7 seconds faster and another 400K less data. So these are improvements that would really speed up and use a lot less data for those websites. The last one to talk about here is lazy loading. And this one is not about just one image. This is the way you build your whole website. So the idea here is if you've got a web page that looks like this and you have 7 images on there, don't load the ones that aren't on the screen. Because if you don't load those ones that aren't on the screen, you only have to load 2 images. The initial page load will be a lot faster. You can use some JavaScript so that when you, with the intersection observer, so that when these appear on the screen, you download them later. And you end up saving a whole lot of data. Not many websites are doing this today. Again, 60% completely fail this. But by lazy loading, by not loading those images that aren't on the screen right away, you can make your page 3.5 seconds faster and use 500K less data on average. And so the way a lot of websites do this is they use preview images. So this is Google image search on my phone, and you can see that these preview images pop into place. These are still downloading, but we've got these small SVGs that are color-coded, green for green, pink for pink, so you get the right image that downloads in time. Customers are kind of used to seeing this. They know an image is coming, and then you don't get the reflows of all the text, which is really annoying when you're reading a web page and images pop in and you start losing where you are on the page. So putting a preview image is a great way to then lazy load in the images later. You can do some really cool things like instead of just a single color, you could use a vector graphic. So this is an SVG that sort of has the impression of the waterfalls. So there's green and white. That's the open source library I use. It's called Squib. But what's really cool about lazy loading, and this is in Chrome, it's under a flag right now, but this is a web page that I built. And so this is the first view, the second view, right? And if you load this page today on the desktop, this is what you end up seeing. And so I just took screenshots. It's not really scientific, but you can see the text loads, and then you can see some of the placeholders load. And then like these images have loaded here, but the images that you want to see at the top of the screen haven't loaded yet. So as a user, you're like, the page hasn't loaded yet, but all this cow down here is all ready to go. And then finally, you know, this last screenshot, you can see there's still one placeholder image here. Like the top of the page hasn't loaded yet. And like these images way down here have loaded. So the page isn't really loading them in a way it makes sense to the browser, but it doesn't make sense to the end user. And so lazy loading is getting built into Chrome today. And so what Chrome does is it lays out the HTML, the text, and then it requests the first 2 kilobytes of every single image on the page. And in that first 2 kilobytes, it gets the width and the height of all the images. And so it actually just puts in placeholder spaces for all of them. And you can see right here the entire page, the text doesn't reflow from number 3. So all of them have laid out. It's downloaded the first 2 kilobytes of all of the images. The page is loaded up. And now because it knows where all the images are on the page, it doesn't request them in random order. It requests them in order from top to bottom. And so you can see by slide 3 here, all of the images in the first screen have loaded, which is what we want to have happen, right? This is where our customers see stuff. And then it starts loading from top to bottom, right? These images load last, which makes sense. It takes a longer for our customers to scroll down to there. So this is really neat because this is coming in the browser. It takes it off our hands as developers for at least one browser. I can only imagine this will flow out into other browsers as well, but I guess Chrome is almost the default now, isn't it? That's a whole nother discussion. We could talk about that afterwards. But so this is the lazy loading. It's behind a flag right now. I believe it's behind a flag in Chrome, so you can check it out if you're interested. It's pretty cool. There are a few bugs right now, at least the last time I checked it out. Images that are right around this the first page view end up being requested twice. So right now there's a bug that is downloading extra data, and it takes a little bit longer. So hopefully they're working on that and fixing it. Animated GIFs. Everybody loves animated GIFs, right? They're awesome. They're everywhere. They're in Twitter. They're on Slack. We use them all the time. This is my goat, Nora, back in Seattle. And, we need GIFs of goats. There's too many cats out there. But the problem is the original video is 1.4 megabytes, and the GIF is 3.8 megabytes. And so the reason for that is when you create a GIF, it actually is a flip book of static GIF images that just play every, if it's 15 frames per second, it just flips through each 15 GIFs every single second. And if you go back to 1990 when the GIF spec came out, there's actually a quote that says, "We've got this animated format, but we really don't recommend that anybody uses it." It's in the spec. That's that ship has sort of sailed in that GIFs are everywhere. But so what can we do to make an animated GIF faster? Well, what if I make it a movie? What if I make it 256 colors, because GIFs are just 256 colors. If I strip out the audio track, because GIFs are silent, it's now 250 kilobytes, and you can pop that in a video tag. Loop, autoplay, muted, goats, and there you go. You have to, even though it has no sound, you have to say muted for a video to autoplay on mobile. And the reason for that is when you're in a meeting and you're surfing the web and you're not supposed to be, you don't want the video to autoplay and be really loud because then you're busted, right? So the Google engineers understand this, and so and Safari as well. So both of them require muted. Video is always the last thing to load on a web page. So you should take that in mind. The files are so much smaller, though. This is definitely the way to go. What's kind of cool is in Safari, you can actually put the MP4 in the picture tag, and it'll load. So this works in Safari. It doesn't work in any other browsers, but this is live in Safari now. So you could put the MP4. It will play. You could do an animated WebP and then fall back to the animated GIF. Now, you might be thinking, but everybody uses GIFs on their web pages. Even Twitter, they have a little thing down here that says GIF in the corner. I don't know if you've seen that, like when you're on Twitter, there's a little chyron down on the bottom that says GIF. But if you ever open up DevTools, they're all movies. So it's fake news. They're lying to us when they say that because they're downloading MP4s. And the reason for that is Twitter and Slack and all these things, they're serving so many of these GIFs that they need to convert them to MP4s for those pages to load quickly. And probably for storage and delivery time and all that other stuff. So if you deliver my goat image as an as a GIF, it takes 22 seconds. If you download it as a video, it's 4.5 seconds. There is an animated WebP format that gets you right in. That's a little bit better than animated GIF, but really you should always go to video if at all possible. I just wrote a blog. I published it yesterday, so I've only added one slide. But I went through the HTTP archive to look at every single website that has animated GIFs on it. Of the 1.2 million, it's like 56,000 sites. And of those 56,000 sites, 35% of them could save over 500 kilobytes in tonnage just by switching to movies instead of the animated GIF. And you start looking at 75%. 75% will save over 100 kilobytes of data, right? I mean, that's pretty huge. If you're looking for a way to save 100 kilobytes from your web page for download time and you have animated GIFs, just removing the animated GIF and turning it into a movie will save you a whole lot of data. And that sort of brings us to video. Video makes up a huge chunk of the internet. They say in the evening, Netflix is like 55% of the internet or something like that in terms of tonnage. And the same things that I talked about for images, that I talked about for web pages, go for video. If a video is slow to load or if a video stalls, people get angry and frustrated and they don't come back to your service. They don't come back to your web page. So you really want to make sure that if you're serving video on your web page, that it loads quickly, it shows up, and that it doesn't stall or buffer. And when you start looking at the video quality metrics that are out there, there are 3 of them that people are worried about. Did the video start playing? Did the video stall? And did the video look good? Those are the 3 top video metrics that the streaming companies look at. So this is data from Q1 of last year, and of all of the videos that were out there, they found that only 86% of them played when somebody pressed play. Now imagine if we were building a web page and it only loaded 86% of the time, right? We would all be out of a job. So what's going on with these? What can we do? Why are these videos not playing here? So 400 million just failed to play, and 2 billion were abandoned. Somebody pressed play and it didn't start in time. So what's causing that? Some of it is stuff like this: geolocation. Oops, this video isn't available in your country. When you open this up in DevTools, you're like, well, that's kind of horrible. And then you realize it took 230 requests and 3.1 megabytes for them to say, oops. I have an Amazon account back in the States. And when I open up Prime Video, it says, hey, you're traveling. Here are the videos that you can't watch. But at least they tell me that I can't watch them. I don't click on it and then get this error message. They're like, when you get home, you can watch these. Here are the videos you can watch when you're in France, or the videos you can watch while you're in the UK. But it's better to say not available in the country you're at before you click than to get all excited and then have it fail. But then we've got these 2 billion that somebody pressed play and they never actually started. So what happens? Akamai found that everybody waits 2 seconds. They press play on a video, everyone will wait 2 seconds. And if you wait longer than, after that, you lose 6% of your users every second afterwards. So if you have a video and it takes 3 seconds to load, you're losing your customers. If it's a short video, people give up faster. So if you clicked on a video of a cat on a Roomba wearing a shark costume chasing a duck, you give up more frequently because after a while you're like, what did I click on? But if you're actually watching a movie, you've already decided you're gonna hang out for like 2 hours. If it takes an extra few seconds for it to start up, you'll hang out. So actually people give up on short play movies faster than long play movies. Other things that I've seen that happen, this is from a mobile app. This is what I'm looking at is the packets here. Right here, the packets are being downloaded. This is the ad. And then the ad downloads and it plays back. You can see no packets are really being downloaded for 30 seconds while the ad's playing. And then the ad is done and they start downloading the movie. Well, think about this. People want to watch the movie, right? So what ends up happening is you get a spinner right here while it's downloading the movie. But the network's not doing anything for 30 seconds right here. What if you just started downloading the movie earlier? Right? Now you've got 15 seconds of download in the buffer, so you can immediately start up the movie right after the ad plays. If it makes sense, preload that video. But I've also seen web pages that put preload equals auto for a video, and what that does in the video tag is it automatically downloads the video. And so this is just some website's homepage. This is the web page test waterfall. And you can see at the end, just this video just downloads. I didn't press play, but the entire video downloads because they used preload equals auto. It ends up being 23.5 megabytes of data that are downloaded every single time this page loads. Can you imagine like the server costs that this company has for their web page? That every time it loads, it downloads 23 megabytes of video. I mean, maybe it's on a CDN, but still, like, that's pretty expensive. Background video is a huge thing right now. So this is a website. You can see you've got this video playing in the background. There's studies out there that show that background videos get you 80% more engagement. That was written by a marketing company that does background videos. But, you know, people will read that and be like, well, we need a background video. That's super cool. Like, I want to take my kids to this place. It looks like a whole lot of fun. I only found this because I was looking through data in the HTTP archive, and the video had a funny name, so I started looking at it. And so the whole video is 5 megabytes, but it has an audio track that nobody hears. So it's downloading, it's only 250 kilobytes, but it's 5% of the file. And by stripping out that audio track, you would make that file a lot smaller, and it would download a little bit faster. The only reason I found it is because the name of that background video, a lot of times it's like, the video name is like background.mp4 or something like that. This one was called Steven.mp4, and I'm like, well, why is it called Steven? And so I started looking at it. But if you're doing a silent video, whether it's like a looping, you know, animated GIF or it's a background video, remove the audio stream. And interestingly, I've found videos that are silent. They don't have any audio, but there's still a silent audio stream. And the fact that the track is there, even though it's silent, it still takes up data. So you should remove the whole track automatically, even if it's silent. It's sort of weird, but just remove it. I found a website that has a 98 megabyte background video that you will see if you're super patient and you hang out long enough, but like 5 megabytes of that was an empty audio track. So this same video that we were just talking about, that background video, it downloads on mobile. You can see it right there, but they have CSS that displays none for the video. So you don't get the video, but it's still downloaded on your data plan. So if you're not going to show the video, don't download it. That 98 megabyte one does the same thing. Like, they have a placeholder image, but they still download a 98 megabyte video on your mobile device. Chrome eventually gives up, but still, it's a bad practice. Here's another background video. This is a web page. Again, you may see this video play if you're patient enough. This is what the background video begins to look like. The first thing we learn about this video is Bob Ross is not just a painter. Bob Ross, anyone? All right, he looks like that. He's a painter. You'll see memes about it on the internet. All right. But the video is 33 megabytes. It's trying to load as a background video. It's 27 seconds long, and it's 2,500 by 1,200 pixels. This is a pretty big video. It's 10 megabits per second playing in the background. You should probably resize your videos to a reasonable size. One thing that's also really interesting is if you rename the file to 720p, that doesn't re-encode the video to 720p. It's new. It is new. But yeah. Sometimes I don't like making fun of it, but it's just too easy. So you can resize that same video. If I resize it to 1080p, it's 8 megabytes. 720p, it's 4 megabytes, right? These are still pretty big files, but we're getting to a little bit more of a reasonable size to have it maybe play when you're actually looking at the web page. A lot of people have asked me, well, why don't I just throw it up on YouTube and like to heck with all this and just let, the people who really know what's going on do this. If you throw it up on YouTube, that's great. There's no initial video download that YouTube waits until you press play before it starts downloading the video. But you can expect 700 kilobytes of extra JavaScript on that initial load, because that's what YouTube does. They have to load a player. And it's about 700K to 1 megabyte. Guys like TED Talks? So TED Talks are really awesome. There's this awesome share button right here. It gives you a one line of code. It's a div. So you can just paste it right into your HTML. And if you do that, that's really awesome. And it downloads the entire video on page load. This is adaptive bitrate, so it'll change depending on the speed of your network. So on a desktop, it was 32 megabytes, 118 requests. If you put 2 TED Talks on your web page, yeah, you get it. So the way video streaming works is there's a manifest file. It gives a list of all the different bit rates that are available, and the player picks the appropriate bit rate. It starts downloading those video segments. They get downloaded into the buffer. You can see this is the buffer right here, and we all know that if there's video in the buffer, the video will play. The way it initially starts out is and then once it starts out, if it thinks it can go to a higher bit rate, it knows how fast these files are downloading. It can estimate the network throughput. It can find that optimal video bit rate. And so this is sort of what a manifest file looks like. We have video bits, we have some more video bits, and then these are all the subtitles, actually, for a TED Talk, and the audio track. But what we see here is there's 2 rows. Here's information about the first bit rate. You can see the bit rate, you can see the codec, you can see the resolution, and here's a link to where all the files are. And so you can see there's a whole bunch of bit rates here. And for HLS streaming, the player always just picks the first bit rate to start. It's got to start somewhere. It just picks the first one on the list. If that bit rate is too high, the buffer takes up a long time to fill. The video doesn't play. The player has to choose a new bit rate, and the video starts playing. Now, of course, the problem with this is we just added an extra bit of time for video startup, which is going to slow down our video startup, which gets us back to 12% of videos never start playing, right? So what can we do to reduce the video startup time? What most developers do is they start with the lowest quality video. Why the lowest quality video? Because it downloads faster, right? And if it downloads faster, the video starts playing super fast. And you've seen this, right? You start watching a video, it's super pixelated for like the first 5 seconds, and then it sharpens. And usually the first 5 seconds of video, it doesn't really matter that much, so you're okay. And then eventually, after a few seconds, it finds that right bit rate and it sharpens up. But I do see some companies that start with this highest bit rate. It doesn't play right away, so the player shifts to the lowest bit rate, and then you end up here. You can see this extra step just takes more time, you lose customers. Then there's this Goldilocks model. Not too big, not too small, but just right. Amazon does this. And the reason Amazon does this is all of their videos are long play, right? It's at least a TV show. It's at least 20 minutes long. They know you'll hang out a little bit longer, and they started off with a really good quality from time equals 0. And if you have an Amazon Prime and you look at their videos, it doesn't start off with a black screen ever. If it's one of their shows, it starts off with something that's pretty detailed, and it always looks good from time equals 0. And that's sort of like the way they differentiate themselves from other video streamers. It takes another maybe second for it to load, but it's really sharp and looks good. It's a high quality video right from the beginning. We can load these up in web page test. When you start with the lowest quality video, no surprise, it shows up on the screen fastest. And then it sharpens up and looks better. When you do the model where it's a higher quality video to start, it takes a few more seconds for it to appear, but this video is higher quality than that video. And then, of course, when you start with the highest quality video, it tries to load the high quality video. It fails. It starts downloading the low quality video. This video looks the same as that video. It just took like 8 seconds longer for it to show up on the screen. So obviously there are pros and cons to all of this. When you start off with this highest bit rate, it looks great on a really fast connection, but for everybody who's not on a really fast connection, it's really slow to start up and initial quality is poor. when you start with a low quality, the quality is low, but it's really fast to start up. And then, of course, in the middle, the initial quality is good, but the startup is sort of in between. So let's go a little bit further into the manifest file here really quickly. This is, again, these are the different bandwidths for that TED Talk I was showing you earlier. And you can see they sort of start off at a medium-high bit rate. And when I was testing on just a 3G connection, what I found was it starts at this higher bit rate and drops to the lowest quality bit rate for the entire video. So you end up watching this video at a really, really low quality bit rate. And I started wondering, I know I have enough throughput to get higher than this because I artificially set the throughput at 1.6 megabits per second. I know it can play better than that. And what I noticed is the bandwidth is set for 1.2 megabits per second, but the actual video encoding is 600 kilobits per second. They're overstating this so that the buffer fills up twice as fast. It's not going to stall, but the problem is you're getting stuck with a lower quality video. So I went to the far extreme and I set the bandwidth exactly the same as what it's encoded to. This might lead to more stalls, but it's going to have a higher quality video that plays back. And immediately what I see, the first thing you notice is the y-axis here changes because the bit rate is lower, right? It's now 600K for that first bit rate. And what I see is it drops to the lowest bit rate first and then quickly recovers. And you may notice that the names are different here. If you ever watch a TED Talk, they have like this intro with the little TED Talk sound, the chimes that play. That's this. And then it goes into the TED Talk. And so they insert this on every single one of their talks. But I couldn't figure out why that dropped down to a lower bit rate. So I went and looked at the manifest of this video, and here is that intro. And there's two things here to look at. One is this is the length of the segment, 5 seconds, and then you can see there's a byte range. And then there's a second one, and then there's another byte range, and then there's a third one and a byte range. And if you look at the ratios of the byte range and the time, they don't match up, right? It doesn't make sense. Like this one is way too long for being 0.1 seconds, and this one is a megabyte for 5 seconds, and this one is like 200K for 6 seconds. Like just, looking at the ratios, it didn't make sense. So I tried to play with the ratios to see if I could make it play better, and I couldn't make it work. And I said, screw it, we're just going to download that whole thing in one segment. It's 12 seconds long, we're going to go for it. And as soon as I did that, it didn't drop down to low quality. So I improved the quality. Now it may stall more often, so there's probably a sweet spot in the middle. With more experimentation, we could find out a way that it doesn't stall as much, but you still end up with the highest quality as possible for as many users as possible. But it's something that you can look at when you're building streaming applications. So with that, thanks everybody for hanging out, talking about images and video. We can optimize our images for quality, format, sizing, and lazy load them if you can. And for video, only download the video if it's going to show up on the screen, especially for your mobile customers. I see that a lot on mobile. Strip out the audio if it's silent. Resize the videos for mobile. Look at your third parties. That's true for anything, right? Ads, JavaScript, everything, but video as well. With streaming, start with a lower bit rate to speed that video startup, but check out different bit rates to reduce stalls and adjusting the quality and things like that. A bunch of the tools I used: web page test, HTTP archive. Some of the stuff for images I used: ImageMagick, structural similarity, lazy sizes, Cloudinary. In conclusion, your images and video can be beautiful, they can be fast, you can deliver performant websites. And with that, I'd be happy to take questions. Thank you. I'm using the question mic. The backup mic. We're gonna.
We have more time to prepare food.
Oh, no worries.
Hello?
Hey.
Hello? Ça marche?
Oui.
Thanks for the presentation. I would like to know one thing. I'm not sure. Does the adaptive bitrate stuff happens at the browser level? So you just put a video attribute in the HTML code, and the browser is handling it?
No.
Or is it handled by some GS JavaScript player code?
You have to add a JavaScript player to do some of the client
If you
work
put
there.
the M3U8 file in a video attribute, it doesn't.
It won't play.
No? Okay.
It won't play. So to do adaptive bitrate streaming today, you need to add a player on your device. There are a bunch of free ones out there. There's a bunch of commercial ones as well.
And they are using some JavaScript API to know the speed of the download?
Yes. Yep.
They ask to download one file, they see the speed, and they change the bitrate they request.
Right.
For
So
the
they
next
know
part.
right. So they know the size of each one of those segments, and they know how fast they're downloading, and so they can estimate what the bit rate is of the network.
Okay.
And they continually do that. So if you're on a train or a bus and you go into an area of lower quality, it will, in theory, adjust the stream appropriately.
Okay, thanks.
Yeah.
C'est les questions en anglais qu'on calme tout le monde. Je suis désolé pour mon accent. Sorry for my accent.
Oh.
I just have a question, because lots of the examples you show and some websites have been audited are just doing absurd stuff like silent audio or a massive JPEG that it resizes to
Right.
very small. I mean, is there, apart from the economical reason saying that it's going to cost you a lot,
Right.
is there any sense of doing the right thing and not just throwing away bytes and bandwidth and?
So there was actually that's a great.
Is there a reason that goes farther than that? Because I know some people just actually don't care.
Right. There's a really good post that came out last week by Tim Kadalik, who does WebPerf, and it's about the ethics of performance. Yeah. And what he's talking about there is, for example, I brought this up for some of the images, like when it has to reprocess the image, it may only take 100 milliseconds on one of our phones. And I say our phones because as developers, we tend to buy the latest and greatest phones and update pretty frequently. Whereas if you buy one of these Android Go devices, it can take upwards of a second. So it ends up taking 10 times longer for the thing to show up on the screen for these lower powered devices. So by doing that, you're effectively pricing some people out of your web page or off the internet by making these pages not being able to load. There's a great experiment. You can find the blog. It's probably about 8 or 9 years old. It's called YouTube Feather. And there's this big issue that YouTube was so huge to load before a video would play. So they built a really lightweight player and lightweight web page, figuring that it would load faster. And then they launched it to great fanfare, and they started looking at the stats, and the load time for Feather was even slower than it was for the original YouTube page. But then they looked at the demographics, and it was people in like Mongolia and people in areas that YouTube just didn't work at all. And now all of a sudden, like, Feather, it sort of worked, and so people were actually willing to hang out and wait for YouTube videos in places where they had really, really, really slow internet connections. So by building something that loads fast on a slow connection, it's also going to load super fast on a fast connection, right? So if you build a web page that takes, 3 seconds to load on a 2G connection, it's going to load in less than a second on a 4G connection. And so that's worth it. I ended up spending some time last spring. Our Airbnb in Ireland broadcast, it advertised that it had a fast Wi-Fi connection. They didn't say that it was connected to a 3G router that was on edge most of the day, right? So it had Wi-Fi. That was an accurate description of the Airbnb. But it didn't really work until 1 a.m. when everybody's smartphones turned off and like no one was using the cellular network. So I was getting up in the middle of the night to work, and it would work. But when your website loads really slowly, if you're in a rural area, it just some of your customers just can't use your service anymore. And if you lose people, you can't just say that, oh, I'm okay with everybody in a rural area not using using my web page. I just looked at OpenSignal. They rank web speeds for different countries, and I think it said for France it's 60-some% are on 4G regularly, but that means that there's 30-some% that are not on 4G regularly. So if you only test your website on a 4G connection, you're not seeing what 30% of your customers are doing. And so that's important to think about.
Yeah, thank you. Another question? Okay, well, thank you.
Awesome. Thank you very much.
Thank you so much.